Hello, welcome to this On Semiconductor webcast. Today, we will discuss power supplies for consumer electronics like white goods, TVs, printers, notebooks, and setup boxes, and how designers can achieve higher efficiency using switch mode and PWM power supply techniques and highly efficient single package solutions. Today, we will briefly talk about the current market trends and consumer needs in consumer electronics. We will touch on solutions and overviews of different types of techniques to achieve improved energy efficiency, and we will discuss the design of each circuit schematic. The appetite to satisfy the needs of consumer has been the prime driving force for innovation and advancement in technology. As a consumer, a product which could provide a single package solution for all needs has become the topmost priority for most companies. With the advancements of technology and innovation, there have been an increase in demand in a consumer's desire for a product that can deliver longer battery life. We don't like plugging in our laptops the whole day. We want something that's compact in size and lightweight. We want something to be high speed and have high performance. And we want it to be cost efficient. The trend in the power supply industry is to strive for smart energy consumption with high performance and consumer end satisfaction guarantee. Products like washing machines and air conditioners are considered to be energy leeches because they consume energy even during standby or no load mode. To put it simply, having a compact and efficient power supply within your air conditioner would reduce your monthly electricity bill substantially. This is achieved using switch mode power supplies, which we will be discussing shortly. We will also discuss power efficiency in detail based on the type of electronic product and how switch mode power supplies have advanced to the next level. The switch mode power supply enables a product to deliver superior efficiency by managing a wide range of power usage. So what's the ultimate solution? How do we find a product and technology to create truly efficient power management? Power management modules can deliver an effective solution for managing power in the energy-craving environment. Integrated modular solutions can provide a viable solution to achieve energy efficiency and power consumption targets, cost effectiveness, and the ability to save valuable board space with a smaller size overall solution. So what do we mean by switching circuits? In layman's terms, it's a circuit which completes its overall functionality based on a switch. As we know, a switch is nothing but a device which has an on and off control. Here's how a switch mode power supply is implemented from an industry level standpoint and what the design considerations are. For designers, the first thing you need to consider is which type of configuration will suit your requirements and design specifications. There are two main types of power supply solutions: switcher and separate solution of PWM IC and EXT switch. Now, a switcher circuit, as you see at the top, is used in products like refrigerators, microwaves, washing machines, and e-meters, which are all connected to the AC supply. These focus on the products. The pros are that they are easy to design and require less components. The cons are less flexibility to cover wide power ranges. On the other hand, PWM IC plus EXT switch are also used in those products, but with a higher power coverage. PWM means controlling or modulating the width of the pulse, which controls the switch. In the next upcoming slides, we will discuss power-specific power supplies and how they support the device efficiently. To summarize, the whole objective of each of the two configurations are to provide a better power management tool for the market. White goods, like refrigerators, microwaves, and washing machines, are various consumer end products which require low cost and high efficiency power management modules. Here, we're going to discuss in depth about the concept of normal switcher circuit and how it has helped attain higher performance and reduce energy consumption in all conditions. The best in-class solution for white goods is achieved using a switcher circuit, as shown in the schematic. Power supplies waste a substantial amount of electricity in the form of heat or power leakage, meaning that for every watt of power supplied to the product, another 3 watts are wasted, hence working as power vampires. How does a switcher circuit help alleviate this? The switcher circuit helps optimize the power supply to function in the most efficient way in terms of both cost and energy consumption. For designers, this is an easy circuit to implement as it uses a switcher MOSFET as switch. This delivers improved efficiency at light loads and no load conditions due to a frequency foldback mechanism. Pulse-by-pulse current limit functions to provide the current form exceeding the program limits, that is, it puts a check on the amount of current based on the output load condition. Hence, it prevents it from wasting the output current unnecessarily. The NCP107X series from ON Semiconductor, as shown in the schematic, has become the standard choice due to low power dissipation. The payoff in deploying a switch mode power supply is that it provides a single package solution for saving power from line to load and a cost-effective methodology that meets evolving global efficiency standards. The key features, as highlighted here, focus on areas of efficiency enhancement in 1. Low standby mode power consumption achieved by low current consumption in standby mode and no load. 2. Low power consumption during startup mode due to frequency foldback, which adapts the overall function of the power regulator based on the load size and requirement. 3. High active power mode efficiency. And 4. Overvoltage protection, OVP, offers increased system reliability, helping products like white goods to operate in rough conditions. OVP protects the system by monitoring the voltage supply during transient conditions. This is a reference design of a switcher circuit implemented on industry-level standard. It's critical for early designers to understand the architecture of this schematic and analyze the characteristics of the circuit. As a note, this design doesn't use bulky transformers or inductors, which will help to save space and reduce power dissipation further. As you can see, the efficiency of the system increases substantially with higher loads and attains high stability. Lastly, this is an easy design to implement due to a smaller number of complex components and lack of timing circuit, as we will discuss for PWM circuits later. Now we're going to discuss portable devices which run on an AC adapter and battery power supply. We will focus on why and how PWM circuit is the best choice for these portable devices. A PWM switch can be considered as a refinement to switcher circuit, and we will discuss here why and how we attain higher level efficiency using the PWM concept. PWM, referred to as pulse width modulation, is a technique for modifying the width of the pulse to control the overall workings of the power supply. It's just like our brain controlling the functions of a body using nerve pulses. Products like laptops and notebooks are portable devices which are designed to run mostly on AC adapters and batteries. For future designers, it is critical to consider a device which works in all conditions just like our laptops. This flexibility and higher power efficiency is achieved using PWM Switch. PWM Switch provides extensive control over the power management module. In simpler words, we expect our laptop to work for a longer time on a single battery charge. The pros of PWM are that it provides more control over the switch by controlling the width of the pulse, provides higher efficiency across the entire load range, and a better standby power. The cons are that it has a more complex number of components, which is more difficult to design. Here you can see an overview of the major features for switch mode power supply. These features provide a broad look into why this circuit can be beneficial for your applications and where it compares with the other current options on the market. These features are also listed on our website for your reference and for comparison purposes. This is a reference design of a PWM circuit implemented on industry-level standard. Early designers should focus on understanding the architecture of the schematic and study the art of modulating the pulse to control the overall circuit before building their own PWM circuit. PWM switch is used in applications that run on AC supply using adapters or battery stored supply. Hence, the design of a PWM switch requires a high level of accuracy and knowledge to build a circuit of your own. Timing is highly critical here. For a laptop to work efficiently on battery power, it requires a timing circuit which controls the battery power based on the user's level of activity. For example, watching a movie on your laptop has a different level of power requirements than typing a Word document. A PWM circuit helps achieve customizable power management for different modes of operation. Now let's look at the graph here. As you can see, the efficiency of the system increases substantially with higher loads and attains high stability. It is also an incredibly easy design to implement for early designers due to the smaller number of complex components and lack of timing circuits, as we will discuss for PWM circuits later. The growing demand of data management and cloud computing has increased the workload of servers and computer power supplies, which is great news. With the increased demand in cloud computing, an energy-efficient server that can manage data efficiently and save electricity costs for the company would be a cost-effective option. In the upcoming slides, we will discuss a specialized switch mode power supply for servers. This is an advanced power supply regulator which is designed for the sole purpose of better distribution of heat across a device. Products like ultra-slim laptops, notebooks, and servers need to dissipate the heat produced inside the system efficiently. This interleaved power factor controller helps reduce electromagnetic interference (EMI) together with reduced switching losses. Now I would like to discuss some of the main benefits that the Interleaved Power Factor Controller has over other similar products. While the Interleaved PFC has more components, it should be noted that it follows a modular approach and contains better heating distribution. The components that it does have are also smaller, more standard components that help create uniformity across multiple products. And as you can see here, two CRM PFCs look like a CCM PFC converter, which eases EMI filtering and lowers stress on the bulk capacitor. Taking all of this into account, we can see that switch mode power supply satisfies all the characteristics highlighted here and at the start of this webcast. With that, we can now see how switch mode can be an invaluable benefit to include in your next application. Thank you for viewing this webcast on power supplies for consumer electronics and the differences between switch mode and PWM power supplies. For more information on the products mentioned here and other products from ON Semiconductor, please subscribe to our YouTube channel and visit www.onsemi.com.